5 that I have prepared to help you revise for that paper 3. Please remember that everything you're seeing are topics that are commonly tested, but we haven't seen yet. So it's really targeted revision. If you're new and you're just jumping in today, then all the other sessions are in the playlist, and in the link below, we have in the description, sorry, there's a link for all the questions. So hopefully you'll find everything that you need. Okay, let's crack on. The first question is a fairly straightforward standard form. I really chose this because I wanted to get the opportunity to remind you that you do have a calculator, and also to just pop one that was a little bit wordy in. So the first one can absolutely be handled by your calculator, and the answer is 104,000. The second one can't. So for this one, you do need to have that skill. Remember, it's a small number, so it will be a negative power, and just be careful with your count. For the last one, we have a number in standard form, and then we are given the information about the total cost of the beans. And they haven't even given that to us in a number. They've used the word million. So we need to change the 300.3 into an actual ordinary number. You don't need them both in ordinary numbers. You can use the standard form because you're just going to pop this into your calculator anyway, and you have got 0.65 as your answer. Okay, next question is an algebraic fraction that we need to write in its simplest form as a single fraction. So the first thing I'm going to do is I'm going to factorize the denominator in the hope that I'm going to see x minus 1, because if I see x minus 1, I can just cancel that off, and I've simplified the first fraction down a little bit before I can, carry on with the problem. So we've got x minus 5 and x plus 1, not x minus 1. So the first plan did not work. However, I do have x minus 5, which is perfect because that's part of the denominator in the second, which means I only have to multiply the second fraction by x plus 1 to get the denominators the same. So I've got 3x minus 1, all bracketed, of course, on the top of the first one, and then I will have minus 2x plus 1 in brackets on the numerator of the second. And I'm just concentrating on the numerator here. I know what the denominator is, so I'm just going to focus in on my numerator. I'm going to expand those out, collect it all up, and I end up with x minus 5 as my numerator. Pop my denominator now in place. I can see top and bottom will cancel, leaving me 1 over x plus 1 as my final answer. Okay, so we are enlarging by a negative scale factor. Again, something that's quite commonly tested and a lot of students aren't massively confident with. Now, my method is slightly different. I'm going to share this with you. I think it's a great method. I wish more teachers used it. We're going to use vectors. Vectors are really easy to write and work with. So we're going to use vectors. And you can see that I've highlighted the corners just to color code so you don't get lost on what I'm doing where, okay? Marked on my center of enlargement, and then I can get going on the problem. So I'm going to write down the vector, the movement, horizontal and vertical, from the cross to the blue dot. I'm going to multiply by the scale factor minus a half. That will give me minus 1, minus 1.5. So from my counting point, from the cross, I'm going to go back 1 and down 1.5. And I've got the corner of my new shape popped in. So now I'm going to work on the next one. The vector is going to be 4, 3, multiply through by the scale factor, and you have got minus 2, minus 1.5. You mark that onto your diagram, and then you do the third point. And I would really encourage all 3 points, no shortcuts, because sometimes they don't do quite what we expect them to do. So get your vector, multiply it through, and then do your count from the cross and draw it in. Simple as that. Now you're still going to need the rays for describing because you need those to help you find the center point. But for drawing, it's great. Okay, so we've got quite a big question here. We are being asked to find the density of our solid. We can't do that unless we have the volume. So volume has been given to us in the boxes. We just need to take really good care. They've explained how the frustum is made. So what I've actually got are kind of two cones. I've got the overall large one that I can see in the diagram, and then I've got the smaller one that kind of gets lopped off. So I'm going to sketch these and pop the information that I know about these two cones. I need to know the scale factor, which is a nice straightforward one of 2. But I wanted to mention scale factor, so we knew that was the step in case it was a bit more complicated. You'll divide your diameter for the large by 2 to get your diameter for the smaller one, which is 3.6. Now we can go on and use the formulas to help us find this volume. We're going to be doing the volume of the larger cone, and please remember to use the radius, half that diameter, and we're going to take away the smaller one. So you get that all set up, and then make sure that you're just really carefully putting it into the calculator. I personally wouldn't put it all in one go. I know how I'm all fingers and thumbs. And also I want to show and communicate to the examiner that I know what I'm doing. So I'm going to work out the first one and separately work out the second one, show those numbers as the takeaway. You can also see that I am keeping quite a few decimal places because I don't want to lose any accuracy. I now have the volume for the frustum, and I can do the sphere. Got to be divided by 2. Don't forget that. We only want half of it. Just popping it all in really carefully. It's just substitution and calculator work. Now, going on to the density part of this question, I can't just dive straight in because the density of the two separate parts of my solid are different. So I know that the volume for F is 76. I have just gone with 76 because my decimal place is so small after, I'm fairly confident that that won't spoil anything. My density is 2.4, and I multiplied through for the mass. Repeat that for the sphere. So for the solid, we're going to add the volume, get a total. We're going to add the mass, get a total. And then our density is mass divided by volume. And we have our result of 3.7500. Now look how good that looks. Keeping those decimal places makes it so easy and clear. All right, so that was a huge question. I do hope it went well. I hope the solution was clear enough to follow if it didn't. Okay, our last question. We've got to work out the area of the triangle BCD. Now, I know from the formula sheet that the area of a triangle is a half AB sine C. So I'm going to write that down and think about what that means. I'm going to need 2 edges and an angle. At the moment, I only have the one edge, 52 centimeters. So I could find the edge BC or BD. Now, it makes sense to find BD because BD is the edge that is closest to a lot of information. So I'm going to find that edge. Looking at what I've been given, 74 degrees is opposite an edge of 39. The edge I would like is opposite 70. So this is working with the sine rule perfectly. So my edge that I want, X, is over sine 70. That is equal to 39 over sine 74. I just need to rearrange, bring the sine 70 across and multiply it through to what's already there. And I get my edge of 38.1249, and on it goes. So I'm going to mark that on the diagram. And then I'm going to need to think about the angle. I've got to decide how to work out that angle. Now, they have made it really clear in the description that I've got parallel lines. Well, they've got to be there for a reason. I know that the angles in a triangle add up to 180, so I can work out ABD as 36, and then there are alternate angles, give me 36. Now I just substitute the information into my formula, and I get my final answer of 582.644. On and on it goes. They want 3 significant figures, so 583. And as I said earlier, don't go crazy rounding too early. If you round too early, you can lose a certain amount of accuracy. 0.6, that could have easily come out at 0.4, and then I'd have had a different 3 sig answer. So yeah, just one to be mindful of, I think. Okay, that's it. I'll see you tomorrow for session 5.